Next, we're going to describe dilutions. I've described how to do dilution calculations in another video. Here, we're going to take a look at the concept of dilution. So when we do dilution, you have an original concentration of your starting material. We call that a stock solution. So solvent is added. Let's put some notes in here. So solvent is added to a stock or concentrated solution, right? So here we have our orange juice. It's a stock concentrated solution, and the instructions tell you to add 1, 2, 3 cans, full cans of water, and then we mix. Now we have a total of 4 cans, right? So if we were thinking of percentages or a ratio, this would be 1 to 3, and the total is 4. So this would be 25% solution. I'm sorry, let me take that back. So we get 1 plus 3 equals 4. So we have 1 to 4 and we have 3 to 4. The actual final concentration is 1 to 4 and we have 25% solution. Okay, so in that concentrate, we already started with an original volume, and then you add more, another volume to have our dilute situation. So out of our concentrated versus our dilute solution, which one has a larger volume? Yes, the dilute solution is has a larger volume than the concentrated solution. So the concentrated solution is volume is less than the diluted volume, okay, when we do a dilution, right? And in the concentrated volume, we start off with a certain amount of solute. We don't remove any volume when we are creating the solution. So the amount of particles that are in our concentrated volume, yes, is the same number of the same number of particles that are in our dilute volume. So the number of solute molecules or solute particles, the amount or the number of solute particles does not change. But the volume does, right? So the number of particles doesn't change, but the volume does. So in the dilute solution, we have the same number of particles, but now we have a larger volume, and so the solution is less concentrated. Okay? So that mass of the solution, the number of particles, is going to remain the same. What is a dilution calculation? Well, since the amount of solute remains constant, only the volume is changed by adding more solute. So the number of moles, so remember molarity is equals to moles per liter. The number of moles never changes in a, the number of moles never changes when we dilute things. So the only things that happens is that the particles, they get spread out, right? That's it, all they do. Notice that we have a darker color in our concentrate and then a lighter color. So in a chemical reaction or in a reaction, and you see that a color goes from dark to light, it's not necessarily a chemical reaction that's occurring. Dilution is going on. Excuse me. So we can use this equation where we have MV when we have concentrated molarity times the concentrated volume divided by the diluted, equals the molarity of the diluted volume per the volume of the diluted volume. So that can also be C1, V1, C2, V2. Does it remind you of another equation that you've used in the past? It's very similar to Boyle's law, where the pressure and the volume are indirectly proportional to each other, and what's constant is the temperature. So here we have constant amount of solute. Since I've already shown you calculations in another video, I'm suspecting that, and if you haven't, please make sure you do,